Hello everyone. In this nugget, we will learn how to update a service. Docker service update command updates a service as described by the specified parameters. This command has to be run targeting a manager node. The parameters are the same as the Docker service create command. Normally, updating a service will only cause the service's task to be replaced with new ones if a change to the service requires recreating the task for it to take effect. However, the force flag will cause the task to be created anyway. This can be used to perform a rolling restart without any changes to the service parameter. In this example, we will create a service which will mount the data1 volume to folder 1. In the next step, we will update the service to mount another volume to another directory inside the service containers. And after that, we will unmount the mounted volumes. So let's first create the service here. Okay. Create replicas we want is 4. And we will name it as nginx update --mount. And the type will be volume. Source will be the data1. Target is going to be r folder 1 and the nginx latest image. So this service got started. So let's verify it. Docker service ls and then Docker service ps with the name of the service with it. Okay, so and we can see all the 4 instances are running here. Let me add another mount for that update command. So Docker service update --mount add type is volume, source is okay, let's type source will be data2 this time, and target will be folder 2 with the nginx update. Now the service has been, let's wait for this. Okay, it is updating. Now the service has been updated. So the service got started. Let's verify it. So Docker service ps nginx. We can see that the previously running instances have been shut down and new instances have been created. Now let's run the update command to remove the added mounts here. So Docker service update --mount rm, and we will be removing the folder 1 here and the name of the service. Okay. Okay, so it is removing all. Now check if the containers got restarted by running the Docker service ps and the service name. Now we can see that the new instances have been created and the previous one have been shut down. Now we will learn about how to apply rolling update on a service. In the previous step of the tutorial, we scaled the number of instances of the service. In this part of the tutorial, we will deploy a service based on the nginx 1.14 image tag. Then you upgrade the service to use the nginx 1.15 container image using the rolling updates. This makes sure that the updates will happen to the instances in the serial manner. You configure the rolling update policy at the service deployment time using the --update -delay flag. It configures the time delay between the updates to a service task or sets of the task. Now you can describe the time t as the combination of the number of seconds, minutes or hours. So let's go ahead and create the service. Earlier services are removed already, right? So let's go ahead and do this stuff. So Docker service create, we are going to use 5 replicas, and the name which will be given will be nginx rolling for this one. --update delay 10 seconds and nginx : 1.14. Okay, now here instead of 10 seconds, you can also give 10.5 seconds or whatever you want to do it. So it will be taken that way. Now let's run the command. The service is being created now. By default, the scheduler updates one task at a time. In the command, we have not specified how many updates to happen simultaneously. By default, the scheduler updates one task at a time. Now we can pass the --update parallelism flag to configure the maximum number of service tasks that the scheduler updates simultaneously. By default, when an update to an individual task returns a state of running, the scheduler schedules another task to update until all tasks are updated. If at any time during an update a task returns failed, the scheduler pauses the update. You can control the behavior using the --update -failure -action flag for Docker service create or Docker service update command. Now let's check the current version of these service instances that we've just updated. Docker service inspect. We will use the pretty flag. Nginx rolling. Now you can see that the version used is 1.14. Now let's update the service. I will use the command Docker service update using the image of Nginx 1.15 here this time. Okay, :1.15 and the name which is Nginx rolling here. Okay, the swarm manager applies the updates to the node according to the update config policy. The scheduler applies the rolling updates as follows by default. Okay, it stops the first task, schedules update for the stop task, start the container for the updated task. If the update to a task returns running, wait for the specified delay period and then start the task again, next task. If at any time during the update a task returns failed, pause the update. Now as we see the update is successful, let's run the inspect command again. And now as you see the version here is 1.15. Now we will understand the draining of a node on the swarm. We will run a Docker node ls on the manager node. All the nodes have been running with active availability. The swarm manager can assign tasks to any active node. So up to now all nodes have been available to receive the tasks. For the previous service, I will run the command okay, where worker 1, 2 and also the manager node, right, we have all of them here. Now sometimes such as plant maintenance time, you need to set the node to drain availability. Now drain availability prevents a node from receiving new tasks from the swarm manager. It also means the manager stops task running on the node and launches replica tasks on the node with active availability. I will run the command docker node update availability set to drain for, let's say, worker 1 node now. Okay, so this will drain this node of all the tasks that are running on it. Okay, now let's run the docker service ps command to see how the swarm manager assigned the task to different nodes. Let's do that. Okay, all the worker 1 instances are in the shutdown state now. I can do grep for worker 1 and all instances will be in shutdown state. So let's check. Yeah. So if I do grep on running instances, we see that there are 5 running instances. Let's do that. Running, right? So there are 5 instances running on worker 2 and manager 1 as worker 1 is in the drain availability state. Hello everyone. In this nugget, we will talk about pending services. A service may be configured in such a way that no node currently in the swarm can run its task. In this case, the service remains in the state of pending. Here are a few examples of when a service might remain in state pending. First, if all nodes are paused or drained and you create a service, it is pending until a node becomes available. Second, you can reserve a specific amount of memory for a service. If no node in the swarm has the required amount of memory, the service remains in the pending state until a node is available which can run its task. Third, you can impose placement constraint on the node. A service can be assigned to. Let's say I want to run a particular service on only nodes marked for miscellaneous activities. It should not run on other nodes and disturb my core task. Suppose you impose placement constraint on a service and the constraints are not being able to be honored at a given time. In this case also, the service will remain in the pending state. Let's talk about the replicated and global services. For a replicated service, you specify the number of identical tasks you want to run. For example, you decide to deploy an HTTP service with 3 replicas, each serving the same content. The services we ran on our Docker Swarm till now have all been replicated services. A global service is a service that runs on task on every node. There is no pre-specified number of tasks. Each time you add a node to a swarm, the orchestrator creates a task and the scheduler assigns this task to a new node. Good candidates for global services are monitoring agents and antivirus scanners or other types of containers that you want to run on every node in the swarm. Now let's go back to our host and we will create a global service. So Docker service create. We will name this as my global service. Mode is global alpine image and it will run the command top. Okay, so now the services are getting created. Okay, so the services are up now. Let me do a Docker service PS on my global service. Okay, as you see, the service was created on the manager 1 node and the worker 2 node. It was not created on worker 1 node because that node was in the drain state. Now let's make the worker 1 node as active node. So Docker node update availability active and worker 1. Okay, so now if I do a Docker ls, it will show all the 3 nodes are active. Okay, now let me run the Docker service PS, my global service. We see that the service got created on the worker 1 instance as well. Next topic in the section of services is swarm mode routing mesh. Docker Engine Swarm mode makes it easy to publish ports for services to make them available to resources outside the swarm. All nodes participate in an ingress routine mesh. The routing mesh enables each node in the swarm to accept connections on published ports for every service running in the swarm, even if there is no task running on that particular node. The routing mesh routes all the incoming services requests to published ports on available nodes to an active container. The request may get routed to a container running on the same node, which has got request or to any other node's containers. To use this ingress network in the swarm, you need to have the following ports open between the swarm nodes before you enable the swarm nodes. So port 7946 on TCP or UDP for container network discovery. This is basically for communication among the nodes. And secondly, port 4789 on UDP for the container ingress network, which is the overlay network traffic. So let's go back to our host to see this in action. Now I'll create a Docker service of Nginx and we will publish it to the external access. Docker service create and we'll be creating an Nginx. Publish Nginx. Okay, published to the port 8000 and the target would be 80. Okay, we want 2 replicas for this one. and running the latest image of Nginx. Okay. So Docker service PS publish Nginx. Okay, so we will take this port numbers and put it here and access it over the 800. So the Nginx is working on that. Right, now let's go back to our other worker one. Let's access the worker one now from this IP at the port 8000 again. And the Nginx is working there as well. And thirdly, we will go to the worker 2 and 8000. Here also the Nginx is working. Okay, so now by default, when you publish a port, it is a TCP port. You can specifically publish a UDP port instead of, or in additional to TCP port. For example, if you run the service again and if you are running it on UDP, so we can mention it as the UDP port by saying protocol as UDP. Okay, so for one service, we can have more than one publish flag set also. So we can bypass the routing mesh so that when you access the bound port on a given node, you're always accessing the instance of the service running on that node. So let's run a service which is using host mode. Okay, so let me create another Nginx service which will be using the host mode. So Docker service create name will be host Nginx this time. Publish. I will use the port as 9000 and the target is 80. Mode we are going to use is host and we will use Nginx. Okay, so the service is starting. Now, if you do a Docker service PS and host Nginx service, we will see that there are two instances running on one on manager 1 and the other one on worker node 2. So let me access it on manager 1 now. So let's grab this IP and we will access it on 9000 this time. Now let's check. Okay, so we see the Nginx is running. Now let's check on the worker 1 and then as expected, nothing is running on worker 1. If you try worker 2 now, okay, so we see the Nginx is running there. So if you use the host mode, then the routing mesh is not applicable for the service. Now let's talk about the control service placement. To reserve a given amount of memory or number of CPUs for a service, we use the reserve memory or reserve CPU flags. If no available nodes can satisfy the requirement for the instance, if you request 4 CPUs and no nodes in the swarm has 4 CPUs available, the service remains in the pending state until the appropriate node is available to run the task. We can also use placement constraints to control the nodes a service can be assigned to. In the following example, the service only runs on a node with the label region set to east. If no appropriately labeled nodes are available, task will wait in the pending state until they become available. The -- constraint flag uses an equality operator which is equal to or not equal to. For replicated services, it is possible that all services run on the same node or each node only runs one replica, or maybe that some nodes don't run any replicas. For global services, the service runs on every node that meets the placement constraints and any resource requirement. Now let's talk about creating services using templates. We can use templates for some flags of service create using the syntax provided by the Go's text-template package. The following tags are supported, that is your host name, mount and environment. So let's go to our manager node and do an example. Let's start an Nginx service with using the templates. So Docker service create, we will call it as Nginx temp. Host name, it has to follow a particular template. So we want node ID to be followed by the service name. So let's give in that one, node ID and service name. Okay. Replicas, we want 3 replicas for this one and with the Nginx. Okay, we need to make changes to, instead of single quote, it needs to be double quotes. Okay, there's a typo there. It's running. Now let's use the Docker service ps command and okay, Nginx temp that we've used. And now let's do the Docker ps to see the running containers. Let's do an exec to this container with a bash, docker exec. Okay. Let's check the host name now. So as you can, as our specification, the host name is in the format node ID plus service name, right? We can check the node ID as well. So let me exit from this container and do docker node ls. We see that the host name is the same as the node ID that we have used. So that is how we can set a common template for all the tasks running for the service. Hello everyone. In this nugget, we will talk about secrets. A secret is a blob of data such as password, SSH private key, SSL certificate, or another piece of data that should not be transmitted over a network or stored unencrypted in a Docker file or in your application source code. You can use Docker secrets to centrally manage this data and securely transmit it to only those containers that need to access it. Secrets are encrypted during transit and at the rest in a Docker swarm. A given secret is only accessible to those services which have been granted explicit access to it, and only while those services tasks are running. Now, when you add a secret to a swarm, Docker sends the secret to Swarm Manager over a mutual TLS connection. The secret is stored in a raft log which is encrypted. The entire raft log is replicated across the other managers, ensuring the same high availability guarantees for secrets as for the rest of the swarm management data. For adding a secret to the Docker, we will use docker secret create command. So let's get back to our host here. So let's have a help out here, docker secret help. You can create a secret from a file or std in as content. Let's use file to create a secret here. So I'm creating a file. Let's just put some text in it and I'll save it as a secret text.txt. Okay. And the docker secret1 and the secret file. Okay. Secret1. This is the file we are creating. Secret text.txt that we have provided. Verify it by docker secret ls. We see that it has been created. Now we will use this secret in a Docker service. We will create an Nginx service and provide access to this secret. So Docker service create. The name is secret Nginx. Okay, the replicas, we are going to go for 3 replicas and the secret. The secret one that we've just created and the Nginx latest image. Okay, so let's see using the Docker service ps secret Nginx. Okay, so this is how we create the secret in Dockers and provide access to these secrets to the running Docker services. Let's talk about overlay networks now. An overlay network is a computer network that is built on top of another network. Nodes in the overlay network can be thought of as being connected to virtual or logical links, each of which corresponds to a path, perhaps through many physical links in underlying network. The internet was originally built as an overlay upon the telephone network, while today the telephone network has turned into an overlay network built on top of the internet. Overlay networks are useful for multi-host networking. You can specify an overlay network for your services. The Swarm Manager automatically assigns addresses to the containers on the overlay network when it initializes or updates the application. It creates a distributed network among multiple Docker daemon hosts. This network sits on top of overlay network, the host specific networks, and allows containers connected to it to communicate securely. Docker transparently handles routing of each packet to and from the correct Docker daemon host and the correct destination container. When you initialize a swarm or join a Docker host into an existing swarm, two new networks are created on that Docker host. First is the overlay network called Ingress, and second is the bridge network called Docker GW Bridge. The Ingress network facilitates load balancing among the services nodes. When any swarm node receives a request on the published port, it hands that request off to the module called IPVS, which handles control and data traffic related to swarm services. When you create a swarm service and do not connect to it the user-defined overlay network, it connects to the ingress network by default. Docker GW Bridge is the bridge network that connects the overlays networks to the individual Docker. Now, so let's go back to our host and do a small demo. So let's do the Docker network ls first. And we can see that Docker underscore GW Bridge, which is the bridge network, and ingress, which is the overlay network, have been created. Similarly, let's go to the worker nodes and check the Docker network ls command. And here also we see that the default networks have been created. Let's now create our own overlay network. On the manager node, I will run the command for Docker network create and the driver overlay. I'll specify the subnet as the name of the network as overlay 1. Let me do a Docker network ls. So we see that the network overlay has been created on the manager node. Let's see on the worker node if this network has been propagated. So I'm on the worker node. Let me rerun the command Docker network ls. We see that overlay 1 is not yet here, which we saw on the master node, manager node. Let's create a service using the custom overlay network now. I'll create a service for Nginx. We want to specify number of replicas as 5. Using the network flag, I can set the custom network and give the name as my web, and of course use the Nginx latest image. Now the service has been created. Let's inspect the service. So now here we can see that the network that has been created saying overlay 1. We will also do a Docker service PS on my web to see where the instances are running. And you can see that the instances are distributed on all the free nodes. Now let's go to the worker 1 node and let's run the Docker network ls command once again. Now we can see that the overlay 1 network has been propagated here. So basically the swarm extends the custom network to each node which is running the service. When the service is created using the custom network, it is propagated on worker nodes as well. Hello everyone. In this nugget, we will talk about Docker Stack. Stack is at the top of the hierarchy of the distributed applications. It is an advanced version of Docker Compose and can run instances for a service on multiple hosts. A stack is a group of interrelated services that share dependencies and can be orchestrated and scaled together. So now let's go to our host and let's see a very simple example of the stacks. I have created a Docker Compose file for this example. So let's go through this file. I'm using version 3 of the Docker Compose, and there are two services used in this particular file. First service is web, and it is using the latest image of Nginx, and I have instructed it to deploy 5 replicas of the service. And the internal port of the Docker would be exposed to the external world on the port 80. The second service is the DB service, and the image that we're going to use for this is going to be MongoDB. Placement constraint defined for this service, which says that the instances for this service should be running only on the manager node. Let's now take a look at the Docker stack commands. So let's say docker stack --help. Here we can see that there are commands for deploying, listing, and also for removing. So if I talk about deploying, so let's take a look at the deploy help. We can deploy the new Docker stack using the deploy file. If we use the -c flag, so let's deploy the Docker stack using the compose file that we have created earlier. So here now I'll run the command docker stack deploy -c, and then we have the Docker compose file. The name of this stack will be stack test. So let's run the command. So here, as we can see, first it has created the network stack test, then it has created the service for the web, and then finally for the database. Let me clear the screen quickly. So now if I run the docker network ls, so here we see that there is this stack test default overlay network which is created. This is on the manager node. If I go to the worker node and run the docker service ls, here also you can see that the stack test default is created for the worker node as well. Now let's take a look at these services created by this stack. First we will do docker service ps for the db. So as we had instructed, it is running on the manager 1 node that we can see here. Similarly, if we list the web service, we see there are 5 instances which are running on the worker nodes as well as on the manager nodes.